So in this unit, we're going to start looking at something called sequences and then something called series. And we're going to look at two different kinds, arithmetic ones and geometric ones. Okay, now this unit it's kind of a mini unit. It's really just kind of a brief overview of these topics. We're not going to go into a lot of depth with them. It's just to sort of introduce you to the idea so that when you get into future math classes where you dig into this a little bit more, you're a little bit prepared to, start working on that. Okay, so we're going to start out today with arithmetic sequences. Okay, so an arithmetic sequence is a sequence in which the difference between any term and its previous term is constant. Okay, so the difference between any term and its previous term is constant. So difference, that's like an addition subtraction word, right? It's subtraction, right? Difference is a subtraction. So it's basically saying that when you subtract any two terms, so any number or any term with the term before it, right? It's always going to give you the same constant answer. So constant meaning the same. Okay, so essentially this is a pattern of numbers where you're adding something over and over and over again or subtracting something over and over again. All right. The difference D, if it's positive, then our sequence is increasing, right? So if the difference between the numbers, if it's a positive number, they're going to keep going up because you're adding a positive number. If it's negative, you're adding a negative number, and we say that the sequence is decreasing. So it could be either. It doesn't really make much of a difference, at least in the calculating math parts. All right, and when we deal with arithmetic sequences, very often a good way to look at them is to consider them as functions. So a mathematical function where the domain, your inputs, is usually the set of non-negative integers. We're going to come back and unpack that a little bit in just a second. So your domain, your inputs are the non-negative integers, and the range is the set of terms in the sequence. Okay, so first of all, notice the word usually is in bold. Okay, it's not always going to be that way, but usually that's the way that we do it. Now, non-negative integers, so integers are positive and negative whole numbers, right? So when we say non-negative integers, we're just basically saying we're including zero. So 0, 1, 2, 3, 4, 5. Okay, and then we map that with the terms in the sequence, and that kind of lets us do some things. Now, not everybody will start with 0. That's kind of a thing that's a little bit different depending on how you do it. So starting with 0 has its strengths, starting with 1 also has its strengths, and it really just kind of depends. All right, now just some terms or symbols and things that you need to know. Terms are what we call the different numbers in the sequence. So for example, this little baby one here, 2, 5, 8, right? This would be the first term, the second term, the third term. Okay, and we call them a sub 1, a sub 2, a sub 3. So in this case, a sub 2, the second term would be 5 because it's the second term in the sequence. So that's what the little 2 stands for. D is the variable we use for our common difference, and N refers to the number of terms in a particular sequence. Okay. All right, now, before we start really unpacking this and talking about, systematic methods of doing this, I want to talk about just an example that we can look at and kind of figure out. So this one, we want to figure out the 40th term in this sequence. Okay, and it's pretty obvious here that we're just adding 3 every time. Okay, so when we take a look at this, I know that I'm going to be adding 3 a whole bunch of times. And the question is just, how many times do I need to add 3 before I get to 40? Okay, because I could just keep adding 3, but that would be annoying. I want to shortcut this. I want to use some multiplication to make this go a little bit faster. Okay, now you probably already have a number in your head, but bear with me a little bit here. Okay, let's think about this. I'm going to think about this as a function, a table. Okay, where I'm going to say that on the left side, my input, my domain, I'm going to go with first, second, third, fourth. I'm going to use these numbers to represent the what number term we're on. Okay, and then the output is going to be my actual sequence, which they gave me 2, 5, 8, and then I can extrapolate and say the next number will be 11, right? Okay, so what we're seeing for our pattern here is that we're adding 3 from one term to the next. So before we talk about jumping all the way to the 40th term, let's look at this limited sphere that we're at here. If I'm starting with the first term and I want to jump to the fourth term, how many times do I have to add 3? Well, 3 times, right? If I'm starting at the first term and I want to jump to the third term, I have to add 3 twice. From the first to the second term, I'm adding 3 once. So you can sort of see that there's a pattern there, right? If I want to go to the fourth term, I'm adding 3. So fourth term, add 3 times, 3, add 2, 2, add 1. So when I jump kind of ahead and say, well, what's the 40th term? I can sort of extrapolate and say, well, it always seems to be 1 less, right? It's 1 less. Like we're talking about the gaps between the numbers that we're adding 3, right? So there's 1 less. So if I want to go from here to here, basically what I'm going to want to do is I'm going to want to add 3 39 times, right? So that's kind of what's happening here. So how I could figure this out, way number 1 is I could just say, well, let me add 3 39 times. Okay, and that would get me to however many it is. Okay, now that's kind of the basic outline of what we're looking at here. So what we're going to kind of do here is we're going to sort of use that to build a formula. Okay, so the idea of what we just did, basically what I just said is I said, well, to figure out the 40th term, we started with the first term, right? We'd start with 2 and we have to add 3 39 times. So I started with the first term, 2, and I added the common difference, 3, 39 times. But how did I get the 39? Well, I got it because between 1 and 40, there are 39 jumping spots, right? So I looked at the distance between 40 and 1, the first term. So the distance between the term that I'm in and the term that I'm starting from. And that's kind of where I calculated this from. Okay, so that's sort of the general idea of what's happening here and what we're kind of looking at. So we're saying, all right, to get to the 40th term from the first term, so I could use this to figure out what the 40th term was, right? I know the first term is 2, and I'm adding 3 now 39 times. That's exactly what we said that we were going to do, right? And when I calculate all of that, that works out to 119. So that is the 40th term in my sequence. Okay, now this is the general idea of what we're doing with sequences and series. Is we're basically just saying for an arithmetic sequence, to get from one term to the next, you just have to figure out how far apart are those 2 terms in the sequence, and then add your common difference that number of times. Okay, so putting this into a formula, I'm going to write out this formula, and then we're going to talk about it, and we're going to talk about the limits, and we're going to talk about how you can use this formula in a more advanced way. Okay, but the general idea of this formula is that to find any given term in the sequence, so any a sub n, right? So any term in the sequence, you start with the first one, and you add your common difference, whatever n minus 1 times is. So we were taking the 40th term, we added our common difference of 3, 40 minus 1 times, so 39. Okay? All right, so that's what this formula is. So let's take a look at this guy here, and we'll deal with this as an example to give you something a little bit more concrete. Okay, so we have the 20th term, and we know the common difference. We want to find the first term. So what I can say is to get to the 20th term from the first term, I have to add my common difference 20 minus 1 times. Okay, that's the basic setup that I'm going to use. And now I'm just going to substitute in the information that I know. I know what a sub 20 is. They told me it's negative 111. I don't know what a1 is. That's what I'm looking for. But I know my common difference is negative 6. And I know 20 minus 1 is 19. Okay, and then from here, we've got a pretty easy equation to solve. So negative 6 times 19 would be negative 114. And when I add that to both sides, I'm going to end up with positive 3. So there we go. That's what the first term in this sequence would be. Okay, so that's the general idea. Now, let's take a look at this next one. So this next one, they didn't tell me what the first term was, right? They gave me the 6th term and they gave me the 10th term, but I don't know what the first term is and I don't know the common difference. So when I look at this formula and I try to apply it, I could use either a sub 6 or a sub 10 as my a sub n, right? But I don't have a sub 1 and I don't have d, and that's going to give me 2 variables in here, which is a problem. Okay, so let's go back to this formula again and talk about it a little bit in a different way. So let's take a look at this example again. And I'm going to just fill in a couple more spots in this table, right? So 5 and 6, we're adding 3 both times. There we go. Okay, so the thing that we can notice about this, right? We figured out to go from the first term to the 40th term, we would add 40 minus 1 or 39 times, right? But let's look at if I wanted to go from, say, the 3rd term to the 6th term, right? To go to the 3rd term, from the 3rd to the 6th term, I would have to add 3 once, twice, and then 3 times, right? So from the 3rd to the 6th term, I'd have to add it 3 times. Okay, so between 3 and 6, it was 3 times, right? Well, what if I started at, say, 2? And I wanted to go from the 2nd term to the 4th term. Well, I'd have to add 3 once, twice. So to go from 2 to 4, I have to add it twice. Okay, well, what if I wanted to go from the 2nd to the 6th term? Well, it would be 1, 2, 3, 4, 5 times, right? Oh, no, I'm sorry, 4 times. 1, 2, 3, 4. So to go from the 2nd to the 6th, that's 4 times. So you're noticing the pattern? All we're basically doing is we're figuring out, well, what's the distance between these two numbers? That's how many times I have to add 3. Okay, so when we look at this formula here, the only reason that this is n minus 1 is because we're finding the distance between the nth term and the first term. But we can generalize this to any other 2 terms in a sequence. Okay, so if I wanted to say, there was some other term, say a sub m in the sequence, I could also say that to go from a sub m from a sub n, right, I would add the common difference m minus n times. Right? To go from this term to that term, I just got to figure out how far apart are they, and that's how many common differences I need to add. So when I look at this problem, if I want to go from the 6th term to the 10th term, I'm going to have to add my common difference 4 times, right? Once to get to the 7th, then the 8th, then the 9th, then the 10th, 4 times. So I'm going to set up my equation in here, and I'm going to say to get to the 10th term from the 6th term, I'm going to add my common difference 10 minus 6 times. Okay, so even though we have this formula here, you don't want to treat this as memorizing a formula and then using it. You want to take the general concept of what's going on in this formula so that you can apply it to any situation, not just specifically starting from the first term. Okay, so now that we have this, now I can use this information, and this is going to let me find D. I know a sub 10 is 39. I know a sub 6 is 25. I don't know D, but I know 10 minus 6 is 4. Right, and now we've got a little baby equation that's pretty easy to solve. That's going to be 14, right? And when I divide both sides by 4, our common difference would be 7 halves. It's a fraction, that's okay. All right, so that's part 1. They asked us to find a sub 1 and they asked us to find D. Okay, so now part 2, I have to find a sub 1. So in order to do that, I'm just going to build from a sub 1 to either one of these 2 terms. So you've got 2 choices. I can either say to get to a sub 6 from a sub 1, add my common difference 6 minus 1 times. Or I could use the other one and say to get from a sub 1 to a sub 10, add the common difference 10 minus 1 times. Either one is fine. You'll get the same answer either way. I'm going to use that one just because it's on the left. So 25, a sub 1, that's the thing I don't know. My common difference, though, we figured out that's 7/2, and I'm multiplying that by 5. So I'm going to grab my calculator, 7/2 times 5, and then I have to subtract that from both sides, right? So 7.5 is what A1 works out to be. All right, and we want to be consistent. Since I wrote that as a fraction, I'm going to go ahead and convert that to a fraction as well and make it 15/2. And there we go. All right, so we've looked at how can we use the starting number and the constant difference to find any term in a sequence. All right, and we've looked at how can I use, well, sorry, that's what we did here, right? We said, how can we use the common difference in the first term to find any given term? We found the 40th. This one, we said, how can I use the constant difference in any random term to find the first term? Now we've used any two random terms to find the common difference and the starting number. And what we're going to do last is we're going to take a look at this one and say, well, let's write a rule for this function, right? This function that we set up as a table here, I want to write an equation for this function. Okay, so how do we do that? Well, I'm going to go back to this general idea of this formula that we had, right? So I know the first term and I know the common difference. So I'm going to say that to get to any given term in the sequence, start with the first term and add the common difference n minus 1 times. The distance between these two terms is n minus 1. All right, I want to write a rule. So a sub n is going to be unknown, but I do know a sub 1 is 2, and I know my common difference is 3. And then from there, I'm just going to simplify this and clean it up a little bit. So I'm going to do a distributive property here. So that'll be 3n minus 3. And then I'm going to combine some like terms. And my rule is going to be 3n minus 1. Okay? And what this will let us do is it lets us shortcut this process. We want to know the 40th term. Well, all I have to do is do 3 times 40 minus 1. So 3 times 40 minus 1 is 119. That's the same answer that we found up here. Okay, so that is our rule for this particular sequence. Now, as a quick side note, an alternate way that you could have done this is just a table. This is like what you did in Algebra 1, where you had a table and you had to write the equation, right? You could also treat this like finding the equation of a line. Calculate your slope, find your y-intercept, right? That's essentially what we did here. Right? If you think about in your little table here, if I had backed up to the 0th term, right? Well, then what number do I add 3 to get there? Well, that would be a -1, right? So my y-intercept is -1. There you go. And my slope, change in y over change in x, is 3/1. There's your slope, right? So this is just y equals mx plus b. It's the same equation. So you could also approach it that way. Right? You could look at this as the point 1, 2, and then 2, 5, right? Where the first number is the number term it is in the sequence. And you could calculate it that way as well. Okay? So that is the idea of an arithmetic sequence. They built pretty nicely. This is also why, as a side note, remember how we said that it's usually you'd use the non-negative integers? Well, this is why. Because if we had started our table and called this the 0th term instead of the first term, it just makes it a little bit easier to find this equation because then you already know what your y-intercept is going to be. Okay, so it's a slight modification that some people do, and you could do it either way. It just sort of depends on, how you're defining your sequence. So that is kind of our introduction to arithmetic sequences. All right, and again, arithmetic sequences is when you're adding or subtracting a common or a constant number over and over and over again. Okay, later we're going to look at geometric sequences, and that's where you're multiplying by a number over and over and over again. So arithmetic is where you're going to be adding those terms.